If it was unfolded, what all the surfaces would be. That's why it says here, draw a net for this thing. Whoops. Draw a net for it first. If you draw a net for this thing, it makes it obvious what the surface area is going to be. If you have a prism that's 6 by 10 by 4, imagine what it's going to be unfolded. Now, obviously, I can't show you that on here. I can show you that cube that we unfolded. I would say, number one, how many surfaces do you have here? How many surfaces do you have? You have 6 surfaces, right? There's 6 of them. There's 6 faces on this thing. You're going to have, it's going to be 6 squares long here, right? Because the height of the thing is 6. Okay? So you have some of them that are 6 by 4. You got that? And then you have one that's 6 by 10, like that. And then you have another one that's 6 by 4. And you have another one that's 6 by 10. And then what am I missing? What are the only sides I'm missing? So I've got this side right here, 6 by 4, and this side over here. Where are those sides on here? That's this one, right? 6 by 4. And this one's 6 by 4, right? And then we got the 6 by 10 ones. 6 by 10 ones are this front one and the back one, right? That's the front and the back. Which ones am I missing here? I'm missing the bottom and the top, right? The bottom and the top? The bottom and the top are how big? What are the dimensions of the bottom and the top? They're 4 this way and 10 this way. So I got to draw some that are 4 by 10. Where do I draw those on here? Does it matter? Can I just stick them anywhere? 4 by 10? Can I just make one here? That's not going to fold up to form that's not going to fold up to form it properly. It's got to be right beside this. Can I put the other one right here? Would that fold up to form that thing properly? Well, it wouldn't, because 2 of them would overlap. They can't be on the same side like that, right? 2 of them would overlap. The other one's got to be on the other side. It could either be here, but it's probably best to put it here, like that. Okay? So there's your net, what the net looks like. You don't have to draw the net to scale. I did on here just so we can match it a little better. But we have the 4 different sides. The front and the back are these ones. Okay? Those things, front and back. And there's that. And then you have the 2, the top and the bottom. Okay, which we can color in. Top and the bottom, this. Pink. Okay? So that's the net for the thing. That's what it looks like. When it's all unfolded. When you're doing surface area, you're just working out the area of each of those. Right? And then, of course, the yellow is the ends over here. The 2 ends. I would say it's best to show surface area in an organized way. Don't just randomly start writing numbers down and multiplying and stuff. Okay? I would personally do it like this. I would say, this I'm going to call area number 1. And I got another one of those over there, area number 1, because they're the same. I would call this maybe area number 2. Got another one over there. And then I'd call this area number 3. You can call it what you want. I would write a formula that looks something like this. Surface area. You can just put SA for surface area. You could do this and say area 1 plus area 1 plus area 2 plus area 2. But you don't have to work that out. You don't have to work that out, each of those things twice, right? There's 6 sides, so you should have 6 sides. The simpler way to do this is, if I got 2 of these, what's the simpler way to write that? 2 times whatever area 1 is, plus 2 times whatever area 2 is, plus 2 times whatever area 3 is. Okay? And then just work out each of those areas. Each of those is a rectangle. How do you find the area of a rectangle? Length times width, right? For the area, you're just doing length times width. That is 6. This is 10. This is also 10, right? The blue one is 10 by, whoops. The blue one is 10 by 6. The yellow one is 4 by 6. The pink one is 4 by 10. You need each of those rectangles represented on here. Area 1 here. Area 1 is the yellow one. So we got 2 times this. I would put down here 2 times 6 centimeters times 4 centimeters. That's the yellow one. Okay? That's the yellow one here. We got 2 times that one. And then we got 2 times area 2, which is the blue one, right? 2 times the blue one. The area of the blue one you come up with as, how big was it again? It was 6 centimeters times how much? What are the dimensions of the blue one? 6 times 10. And then the last one here is the pink one, top and the bottom. 2 times, that one is 4 centimeters times 10 centimeters. So we got each of those areas here. If you multiply this out, we got 2 times 24, we got 48 square centimeters. If I counted up all the little squares in the yellow thing, if I go 1, 2, 3, 4, 5, if you start counting all of those, you got 48 square centimeters. Okay? That's the 2 yellow things all together. If we multiply the other part out here, 2 times this blue thing, we got 60 times 2, we got 120 centimeters squared. That's the area of all the blue ones together. 1, 2, 3, 4, and you count it up, right? And then if you want to do the last one, okay, the 2 pink ones together, how much are the pink ones? Each one of them is 40 centimeters squared. So we're going to have 80 centimeters squared. If you want the total surface area of the whole thing, what is that going to become? The total surface area of the whole thing? I can add all 3 of those together. I'm going to get 248 centimeters squared. Notice area is centimeters squared. It's in square units. Let me double check it's centimeters. Yeah, it was. Are we okay with that idea? Is it any different if it's a different kind of a shape? Don't try to memorize this as a formula. For surface area, the best strategy is to write your own formula each time. Draw a picture of what it looks like unfolded. Draw a net. And then write your own formula. On the Math 10 provincial exam formula sheet, they give you formulas for volume, but the surface area usually just says, surface area is sum of all the surfaces. Seems pretty obvious, right? You need to write your own formula each time. For any of these other shapes here, if that thing was different, let's say that thing was different such that this wasn't 6, this was 4 centimeters. Let's say that was 4 centimeters, so just pretend it was 4 centimeters. Because that's kind of almost how the picture looks. What if that was 4 centimeters? Would you have 3 different types of shapes here still? Would you have 3 different types of shapes? If that was 4, then this whole thing would look like this, wouldn't it? How big would the ends be? Would this be like this? Let's get rid of the colors here for a second, okay? Come on. Let's get rid of these colors, the shading here for a second. If we can do this quickly. Get rid of the shading. Okay. Let's say that was 4. How would my net look different here? How would this look different? Can you watch? This would look like this. Actually, I got to shrink these ones down here. How would these ones in the middle be different here? They would be like this, right? Wouldn't they be like that? Do you want to see that again? Those ones would look like that, wouldn't they? And then this one would obviously be stuck to the edge. And what would you have then? Would you have 3 different things? Would we have to call these area 1, area 2, area 3? Which ones are the same now? Let's pretend it was that. I just want you to think about how it's different here. I just want somebody to think, period, but right now. How would that be different? Which ones are the same? Which ones are different?
No, they're the same.
How many of these ones do you have? If this is area 1, how many other ones are like it? There's 3 other ones like it, right? And then you could call this area 2 if you want. If you were doing that, your surface area formula would look like, it wouldn't say 2 times area 1 plus 2 times area 2 plus 2 times area 3. What would it look like? Absolutely. You'd say 4 times area 1 plus 2 times area 2. You have to write your own formula each time when you're doing this. Based on, sometimes you're going to have a triangular prism where there's 4 different shapes. Like, there's only one of each rectangle plus there's 2 triangles. All right? So you got to think about the formula and write your own formula, starting like that. Don't just assume, okay? Can we get going on working on that section? Do your stuff in an organized way. I'd really advise you to try and do it in a way that makes sense, starting like that, with a picture and a formula. Okay, get going and finishing that, including the assignment.